Here we go. Problem 5-80. Consider the equation y equals the quantity of x plus 6 squared minus 7. Letter A. Explain completely how to get a good sketch of the graph of y equals the quantity of x plus 6 squared minus 7. Well, if I was looking to get a good sketch of the graph, I would first get my locator point. My locator point is going to be the point HK, remember. So our HK here would be -6, -7. That is also going to be our vertex. So we know we have a vertex at -6, -7. This parabola, because the A value is 1, would open upward. So it would open upward. And remember, it would have the same shape as our parent function. That says graph right there. Thank you. Letter B. Explain how to change the graph from part A to represent the graph of y equals the quantity of x plus 6 squared plus 2. Well, if we think about our locator point on this problem, it has changed from -6, -7 to -6, +2. Well, remember, K is how far up and down we are going to slide or translate our graph from the origin. In this case, we have gone up 2. We had started 7 below. So that's going to be a difference of 9 units. We've traveled in the northern or upward direction. So I would say we are going to translate the graph up 9 units. Letter C. Given your original graph, how can you get the graph of y equals the absolute value of the quantity of x plus 6 squared minus 7? Well, in this case, since we're talking about the absolute value, our part of our parabola that would have been below our x-axis is now going to reflect above the y-axis. So let's take a little peek here. First of all, I'm going to go ahead and put in my original function. We had y equals the quantity of x plus 6 squared and then we subtracted 7. There is our original graph. Now, if we take it here, and we can't have any parts below the x-axis, what's going to end up happening here is our graph is going to reflect this portion above the x-axis. It's going to kind of look like a W, because it'd be like a winner. Let's take it and check it and see if we're right. So I'm going to do that on a separate function. Remember, absolute value, math, right, number 1. We have the quantity of x plus 6 squared minus 7. Let's take a little peek here at what that graph might look like. Oh, so we were right. Very good for us. Our parabola comes down, but instead of going under the x-axis, it bounces up and goes over, and then goes back up. Got that nice little hump in there. So if we want to answer the question for this one, we would say reflect the portion of the graph that is below the x-axis That's terrible writing. I can't live with that. So reflect the portion of the graph that is below the x-axis above it. Or you can word it however you wish. Letter D. Restrict the domain of the original parabola to x is greater than or equal to -6 and graph its inverse function. So we need to restrict the domain of the original parabola so that it is just x is greater than or equal to -6 and then graph its inverse function. So what we're going to focus on here is this. Let's go back. Let's eliminate what we don't need here, the second function. And when I graph this one here, I'm going to cheat. I don't advise cheating, but I'm going to pull it out here. The part that is going to be greater than or equal to -6 is this part right here. So my graph will contain just this portion. So we'll make this blue. I'm just tracing over it so you can see it. I'm not the best tracer. But you get the point, I hope. We don't want these ones here because if we have a restricted domain, that will cause our inverse to not be a function without it. For instance, we wanted to graph the inverse. We know that we could take our points that we have here, and I will get those from my calculator. Remember, our values need to be greater than or equal to -6 for our x. So we're looking at these values here, -6, -7, -5, -6. So let's do this. Whoops, that was not what I wanted to do. Let's copy those down. -6, -7, -5, -6, -4, -3, -3, -2. Sorry, +2. I was getting carried away. Then we have -2, +9. -1, +18. And that should be good for that. This is our original. Now to graph the inverse of this function here. Remember, all you need to do is flip-flop your x and your y's. So I'm going to do that right now. And then I'm going to take the time to plot them on here. So -7, -6. I'm going to go back, -7. Then down -6. That would be 1, 2, 3, 4, 5, 6. We have a point about right here. Then I'm going to go -6, -5. To be about right here. And then we're going to go -3, -4. So 1, 2, 3, 1, 2, 3, 4. Then we've got a 2, -3. We've got a 9, -2. And what we come up with is a function that looks like this. This is our inverse of this function. It should be a reflection over the line y equals x. So what would be the equation for the inverse function if you restricted the domain to x is greater than or equal to -6? Well, we've got here, we could take this and we could go and flip-flop our x and our y. So y equals the quantity of x plus 6 squared minus 7. If we flip-flop our x and our y, we've got x equals y plus 6 squared minus 7. Now let's solve this for y. Let's add our 7 to each side. So x plus 7 equals the quantity of y plus 6 squared. Let's take the square root of each side. So we've got the square root of x plus 7 equals, and normally we would take the absolute value of y plus 6 squared there, we would end up with the absolute value of y plus 6. But since we're only focused on the restricted domain, we're going to end up with just y plus 6 on this one. Because this part will be the only part that is the inverse to this part. Then we're going to subtract our 6 from each side, and we get the square root of the quantity of x plus 7 minus 6 equals y. We'll list that over here. We've got y equals the square root of the quantity of x plus 7 minus 6. This is your inverse to your original function. This is problem 5-80. If you have further questions, please make sure you ask your teacher. Thank you for listening. I hope that you learned a little bit